So my screen is visible to everyone?
Yes, sir.
Yes.
Okay, good. So today we are going to discuss more about the virtualizations. And in the virtualization, we will discuss very first thing that is an interesting topic is the configuration part. We'll try to understand definitely we'll discuss about the virtualization concepts as well. What is the virtualization? What is the hypervisors? How the hypervisor is going to be make the connectivity, virtual machines, virtual switching. These all I'll definitely show you. Even I will try to show some practicals as well. And also we'll discuss about the LIPS protocols, VXLAN. We just have to understand very high level. We don't have to do any lab and all. But yes, we should know what is the VXLAN and LIPS. But the configuration point of view, we have to understand the VRF and GRE and IPSEC. So I will start with the GRE and IPSEC concept, and we'll try to understand what is GRE, what is IPSEC, and then we'll talk about the VRF. So this is the agenda for next 2 hours. We'll try to cover these two topics. If time allow, we'll discuss about this virtualization as well. So let's start. So first of all, we have to understand, if you go in the CCNP and CCIE book, you're going to find the topic that is the overlay concept. In this overlay concept, if you go and drop down, we are going to find the GRE. So we have to understand GRE, then we have to understand the IPSEC, then LIPS, then VXLAN. So the all topic under the virtualizations that are come in the overlay concept in the ebooks. So we have to understand one by one. So what is the GRE? First, we have to understand, right? That is known as the generic routing encapsulations. And also we'll try to do lab. So let me open the lab as well. Let me see. Yeah. So let me see another lab I should have. This is the one lab. Okay, let me open this lab only. Okay, no problem. So this is a GRE lab. You can see there is a tunnel and all. So I will just wipe out the configuration. I have given some configuration because it's GRE and IPSEC configuration a little bit complex. So I given the configuration as well, just for the reference in case you want to refer it. So you can just refer it. If you don't want to refer, you can just, delete from your topology. There is no problem. So how this IPSEC and GRE is going to be built and how the connectivity is going to happen, that we have to understand a step-by-step process. Okay. So let me turn on the devices. And first I will explain the concept, then I will talk about the lab as well. Let me, why not I'm able to open this one? Okay, this is basically creating an issue. Okay, now it's fine. Okay, all right. So let me turn on this router as well. So it will take a little bit less time to get ready. No. And also in this switch, we're not going to make any configuration. This is my one user. This is another user. So the end goal is how we can make the communication between the two different users, which are on the different two sides. Okay. So this is going to be my enable config T. Let me put the host name. Host name site A router and do right. That's all. I'll go here and put the host name, enable config T, and host name is going to be site B router. Okay. And do that. That's all. So let's understand, okay, what is GRE and why is GRE is going to be very important. So GRE, you can know, it's a encapsulation protocol. GRE is a encapsulation protocol which used to build a tunnel. Means if you want to make a virtual tunnel between two routers, right? So this GRE is going to be used, and this is going to be encapsulate your IP packets, either IPv4, IPv6, IPS, whatever you have, right? So it's like a method where you can just, encapsulate the IP packet, and based on that encapsulations, you are going to be just add a new header, right? And based on new header, you're going to be send the packet from one location to another location. So you can see the GRE IP header. So original IP header and data is going to be encapsulated, and the new GRE flag is going to be added, and new GRE header is going to be added. And based on that GRE header and flags, the packet is going to be travel from one location to another locations. So this is just tunneling protocols, right? Cisco base, and this is a Cisco proprietary. You can see probably it's a mention somewhere, but it's a Cisco proprietary GRE tunnel where it's going to be use this virtual network point to point, and even for the MGRE is going to be there. That another protocol, that is the MGRE. MGRE is going to be used for the multi-point communications. Means one location have the multiple tunnel with different location. That is also going to be used. But GRE is going to be point-to-point communication. In this GRE tunnel, you can send any kind of traffic, either unicast traffic, multicast traffic, broadcast traffic. Means whatever traffic you have, you want to send that, it is possible to send the GRE tunnels. That's why you can see GRE tunneling protocol that provides the connectivity for to a wide variety of the network layer protocol by encapsulating and forwarding packet over the IP-based network. GRE was originally created to provide the transport for the non-routable legacy protocols such as the IPX across the IP network. Means you once you encapsulate the any non-routable protocol, and by adding the new header, your packet is going to be transported. That's why initially GRE is going to be used, but now GRE is going to be very well used in everywhere, especially for the MGRE. MGRE is like multi-GRE, where DMVPN is going to become in picture. In NRC, we'll see how DMVPN is going to build and how MGRE is going to be there. So this is going to be created, whatever your original packet is going to be there. That original packet is going to be completely encapsulated. And in top of that, you're going to add a new GRE header, and basis of that, you're going to make the communication. But one very important thing, whenever you're going to build a GRE tunnel, whenever you're going to build GRE tunnel, the GRE tunnel are not a secure tunnel. Means anything you are sending over the GRE tunnel over the public network, it's going to be always unsecure. And if it is unsecure, that means it is easily going to be compromised. Means let's suppose there is an internet connectivity and you building the GRE tunnel over the internet connectivity. And in case of that, because the packets are not very secure, not encrypted, so anyone sitting on the internet, any hacker, any man in the middle, he can or she can easily going to grab your informations, and based on that, they are going to be just understand what packet you're sending, what packet you're receiving. So man in the middle is going to be attacked, and it's going to be compromise your packet. Okay. So GRE is always unsecure. But when you're going to add the GRE over IPSEC, we'll talk about that. GRE over IPSEC. That means your GRE is going to be completely secure. So IPSEC is going to give the complete fundamental of the security. Means it is going to give the encryption method, authentication, data integrity, and based on that, your packet is going to be end-to-end secure. So let's understand first GRE, how you can going to build a GRE tunnel. If you want to build a GRE tunnel, what is the prerequisite? So anytime if you want to build a GRE tunnel, so very first thing, any place you want to build a GRE tunnel, so you have a one router R1. This is going to connect over the internet. So when you're going to build a GRE tunnel, your circuit should be internet, and there is a R2 router. So you want to build a GRE tunnel. Let's suppose this is my GRE tunnel between these two routers. Okay. So what is the prerequisite to build a GRE tunnel? To build a GRE tunnel, prerequisite, you should have the underlay reachability. Underlay reachability means we have the one IP here, another IP here, one IP here, another IP here. And these all are going to be your public IP address, because GRE is generally built on the public IP address. So the underlay is basically basic IP reachability, basic IPv4 or IPv6 reachability. So if you don't have this reachability, means you're not able to ping from here to here, you cannot build the GRE tunnel. Even you're not able to ping from here to here, means generally your ICMP packet just for testing, but in case of GRE, you need to allow the specific. Let's suppose you don't want to allow ICMP, but still you have to make sure your packet should be there. Means GRE packet should be tables or might be the every kind of the negotiation to build the GRE tunnels. That is going to be allow. If there is no allow, that is not going to be like allow the build a tunnel, right? So give me 1 second. So your packet should be allowed any case. Means likewise, we have the IPSEC. IPSEC also use the different protocol. Like they use the AH protocol, they use the ESP protocol, and they use the port numbers, right? 50 and 50 and 51. They use the port number. Similar in the GRE, they use the protocol number 47. So if you want to build that particular communication, so you must have to allow, let's suppose there is a firewall and you want to build the communication. So this port should be allowed. If this port is not going to be allowed, you are not going to make any communication. So even you're going to find this port number in somewhere in the book as well. So no, it's not mentioned here. But if you go in GRE protocol number is going to be 47. It must be there. So your public network should be there, and based on that, they're going to communicate. So how we can build these tunnels? So if I want to build this tunnel, let's suppose this site want to talk to this site. So I want to see whether my traffic is going via underlay or via overlay. So overlay should be built other tunnels. Tunnel is always considered as overlay. My IP reachability is going to be underlay. So let me first build the basic reachability. So I can open this one as well. This is another internet router. So let me configure this router as well. So this is my ISP router, and I'll go on the ISP router and I'll assign the IP address. So I will go here, config, and host name is going to be internet. This is my undo show IP. In this, you can see Ethernet 0 by 1, 0 by 0, sorry. So I will go here, Ethernet 0 by 0, and I will give the IP address. This IP address is going to be 112.16.10.1. 112.16.10.1, 255.255.255.0. Simple. I can /30. So I need to give that 252/30, and you can just make the no shut. Now I'll go in the another interface, Ethernet 0 by 1. And this is going to be IP address, public IP address 110.15.11.1. And that's all. Do right. So my configuration of the router, ISP router has been completed. No more configuration needed. I just need that much configurations. After that, I will go on this site A router and I'll assign the IP address. So I'll go in the config team. Interface internet address is going to be ETH 0 by 0, and IP address is going to be 112.16.10.2. 16.10.2, 255.255.255.252. No shut. So I'll ping first point to point after assign the IP address. My ISP should be reachable. So I can simply go here and try to ping. Okay, one more thing. I need to give the default route pointing toward the ISP so they can build the communication. So one default route here toward the ISP, one default route here toward this ISP. So I need to give the default route. So how I can give the default route? Always any internet, you have to give the default route either via the BGP or via the static. And next stop is going to be this one. One more thing, I also configure this LAN interface from where my traffic is going to be come. So LAN interface Ethernet 1. So I will go Ethernet 0 by 1. IP address is going to be 192.168.10.1. So 192.168.10.1, 255.255.255.0. No shut and do right. So my configuration of this particular site A router is also completed. You guys can see here, I just assigned two LAN, means one LAN interface, one WAN interface, and one more thing, I given the static route pointing toward my ISP. Similarly, I will go in the router B, and router B also I will do the similar thing. So I will go in the router B, I will go in the configuration. Interface is going to be my this one, Ethernet 0 by 0. 0 IP address is going to be 1110.15.10.2. Let me see. Sorry, 11.2. 255, 255, 255.252. No shut, and I will try to ping 11.1, which is my ISP side IP address. So I will use do ping. Okay, it's done. Also, I will assign the one of the default route. And after that, I will configure my LAN interface. This is my LAN interface, Ethernet 0 by 2. Sorry, Ethernet 0 by 1, not 2. IP address is going to be 172.16.10.1, 255, 255, 255.0. No shit. Now do right. How I can verify the underlay connectivity? So underlay connectivity should be, if I'm in this location, I can ping from this address to this address. If they are not reachable, that means my underlay is not fine. I need to work my underlay. So this should be reachable. Means I can easily able to ping from here to here and here to here. Then is my underlay is going to fine. So how can I verify? I simply go in the site A router, ping, and I will try to ping that address. Let me, what was the address? This one address. And should be reachable with source. What is my source? Source should be this address, my local interface address. So you can see you are able to reach. Even check without source also. So source should be very important. Your source should be reachable. So you're able to ping your another peer IP address. That is very important. That is going to confirm your underlay connectivity. Even you can try from this location to this 1112 as well. So if you want to verify 1112, so go here and try to ping. See, it is also reachable. So that means my underlay is fine. Now, how I can build my tunnels on it? How I can build my tunnel it? So it's very easy to do your GRE tunnel configuration. It's very easy to do the GRE tunnel configuration. You can see whenever you want to build tunnels, you have to make sure, even you can see you have the default route. You can see the same topology and you have the reachability. It means you're able to ping point to point. But to configure the GRE tunnel, you have to define some sort of the interface configuration. That is a virtual interface configurations. Means you have to create a tunnel interface, any tunnel interface, virtual tunnel interface on the both side, and you have to give some bandwidth, some IP address. Tunnel source is going to be your this interface, your local WAN interface. Tunnel destination is going to be your remote public IP address. Similarly, here you go there and define the tunnel interface. Then you can define the bandwidth. Then you can define the keep alive message and all, and then you can define the tunnel source and tunnel destination. Then it is going to build your tunnels, right? So you have to do this all configuration, right? IPMTU, why IPMTU is at 1400? Because whenever going to add the means encapsulate the packet with the GRE tunnel, it is going to exceed the your maximum MTU size. Okay, so if you go here, IP packet plus GRE is equal to MTU. So you're going to see GRE is going to add 24 bytes header extra. So by default, standard MTU size is going to be 1500. But the moment you're going to be add this byte, it is going to be more than 1500. So your packet is not going to be accepted by the interface. So you always have to do the fragmentations. So always you have to make sure set the tunnel MTU lower than 1500. Okay, at least 1474 should be there, or it's recommended to go with the 1400 if you're adding the IPSEC as well. Later on, we have to add IPSEC as well. So that's why you have to add the 14 because you have to make sure IPsec packet also going to be there. If you add the IPsec as well, it's going to be even bigger packet size. So you can see it is going to be almost 60 to 90. So GRE is 24, right? And 36 to 64 byte is going to be IPsec. So we're going to add these two, it is going to be around this one. And that's why the optimal MTU is going to be 1400. Else your packet is going to be fragmented and it is going to create a problem. So always focus on the MTU. MTU should not be default in case of the tunneling, in case of the IPsec, in case of the GRA. Is it clear, Battalion, Amrita, Himari, Sridhar, Sheikh? This one is clear, right?
Yes, sir.
Okay. So always work with the MTU. So in that case, I will set the MTU 1400. There is no problem for that. And then keep alive is just going to make sure keep alive means every 5 seconds the packet is going to be sent. And if 3 times there is no reply, then it is going to declare the packet is dead. So let me do step-by-step configuration. I'll go in the R1 and I'll create the tunnel interface. And interface, I'll create tunnel. I can put any name 101. And I can give the IP address. You can take any IP address, random any IP address, private IP address. Even I want to take the 10.10.10, you can see tunnel is already there, 101, 172.15.10.1. But I want to take 10.10.10. It is also possible. Tunnel IP is totally should be different than your LAN and the WAN. And this is the private IP address. Okay. So I can create a tunnel like a 172.16, 15. So 172.15.10.1, 255, 255, 255.0. IP MTU 1400. Okay. Keep alive. See, keep alive is going to be how many default? 10 seconds is going to be there. But if I'm going to send 5 seconds and keep how many time you want to declare means if 3 times it's going to send the packet and there is no reply, then it is going to declare it's a dead. So you can put the 5 and 3. So this is the meaning 5 of 3. Clear? Means every 5 seconds they're going to send a keep alive message. If 3 times there is retry is going to happen. You can see there is a retry. If retry is going to happen, keep alive. If there is no reply after 3 times, it's going to declare this is a dead. So this is a keep alive. Now after that, you can give the tunnel source interface. What is my tunnel source interface? This is my Ethernet 0x0. So you can give tunnel source as a Ethernet 0x0. And tunnel destination is going to be your IP address of the WAN. So what is IP address? This remote router 1110.15.11.2. So I will go here and put this address and do right. That's all. You can just go and show run tunnel 101 configuration, show run interface, tunnel 101. This is your configuration. You can just use the same configuration. Let me copy.
Sir, I have one doubt.
Yes, please go ahead and ask out.
And the tunnel IP is a public IP or it's a private IP?
Private IP address.
Private IP, but 172.15 is a public IP, right?
Yeah, we can 15 is public IP address, but you can use the private IP generally we use, not public IP address. Just I use in the lab, but you can use the public IP address as well, but lab just 15. Just why I use the 15? Because it's going to class 16 with this subnet. You can see. So just to avoid the classing, I use the 15 here. So you can use private IP address most of the case. In some cases, you're going to use the public IP address, but 99.9% you're going to get private IP address only, tunnel interface. So another side is going to be .2 and IP interface tunnel 101 and source is same. This is going to be your 112.16. Let me see 10.2. So this is another side configuration. So I'll copy this. I'll go in this my side V router and I'll configure. Do right. And show run interface tunnel 101. Now you can see if I run command show IP interface brief, you can see tunnel is showing up and up here as well. And you can see here also must be tunnel up and up. So if I ping from this IP, if I ping from my tunnel 2, it should be reachable. So you can see I'm able to ping my tunnel interfaces. Means from here, I'm able to ping here tunnel IP address. That is very important. So my tunnel is up basically. So if you go here, show interface tunnel 101, you will see my protocol, line protocol, tunnel is everything is up. So how I can do the routing? So my tunnel is going to carry the routing. So my tunnel is built. So now understand how the communication is going to happen. So now I want to make the communication from this PC to this PC. But I want whenever the traffic is going to come, my traffic should come here and hit under the tunnel and then it is go via this one, not via this path. No, it will not going to take my default route. It should take my the tunnel interface to exit from traffic, right? So my trace should show the tunnel interface, not this all interface. Clear? So how I can do that? For that, for this subnet 172.16, you have to put the you have two options. So you can use the dynamic routing protocols. Might be I can enable the OSPF between these two tunnels. So by default, I will advertise this network and it is going to make the communications. Or I can use the static route. I will put the static route. See, this router having the static route, IP route, already toward a default. But this time, I'm going to put this subnet static route toward next hop as a tunnel. So what is the route is going to be there? I can put the static route, IP route 16.10.0, 255.255.255.0. Next hop should be, I can put tunnel 101. That's all. Or I can put the tunnel IP address. That's the way my traffic is going to happen. So this is done. So now you can see I have the new static route, enter here, this one. And you can check here, show IP route, you will see there is a default route and there is a static route via the tunnels. So you now have the two static route available. Similarly, I'll go here and put the one more static route here. I'll go here, IP route, and this time 192.168.10.0, 255.255.255.0. Next hop is going to be tunnel 101. Now you can see in the routing table, we have the two default, one default route, one static route. So if anything coming from default means anything not coming for this destination, they will follow the default route. Anything coming from this destination, it is going via tunnel. So if you go and check here, show IP route, you will see this is also have the different static route. Let me write. Now let me go in these two PCs and assign the IP address. So show IP, there is no IP. So I can go here, IP address. This is my site A. So this is going to be 192.168.10.10. So 192.168.10.10/24. Gateway is going to be 192.168.10.1. And I will save the configuration. Okay. You can ping gateway should be reachable. Yeah, very reachable. Now I'll go in the site B router, show IP. There is no configuration at all. And I will go here and define the IP 172.16.10.1/24. Sorry. And I will just simply save config. Okay, now you can try to ping the gateway. Gateway is built. So now you'll see my traffic is not going to follow via this one. It will go via tunnel. How you can just let's try to ping from site A user, try to ping site B. Site B is 192.172.16.10.10. And it's reachable. But how the traffic is going? It's going via this path or via tunnel. How you can check that? The best way you can take a trace. Trace and just put this, just put this address. See? So is it going by underlay or it is going by overlay? Any guess? Guys, how the traffic is going on? This
Overlay.
overlay. This is a tunnel, na? This is a tunnel. So it is going via a tunnel. Another way you can do another thing. You can go here and go on the router and capture. So basically on this interface, let's suppose WAN interface, I'm trying to take a capture of the packet. So, but trace clearly showing that my traffic is going by the overlay. So my tunnel is actually handling the traffic right now. Tunnel is actually handling the traffic from one location to another location. Let's wait for a while. Okay. So now you can see GRE packet, you can see here. So if I go here and initiate the again trace, you'll see. You can see GRE packet here. Means GRE negotiation is happening and tunnel is actually going via the GRE. So if I go here, let me first stop this packet. Apply filter, why it's not showing apply filter. GRE protocol. Okay, just go. There's a protocol. You can filter here protocol. Let's go to okay, leave it. I need to check filter. What is a filter for GRE? So you can see here, if you go here and check the packet, your traffic is just going via this. So any communication you're just doing that, you can see ICMP you're doing from this to this, right? But this ICMP packet, this ICMP packet is coming, but they all are going by the GRE because GRE negotiation is happening via this one. So you cannot see that the ping packet is not going to show that GRE, but when negotiation is going to be there, you can probably find here. Let me show you. See here, GRE packet you can see. So even the packet you have the GRE flags, and you can see GRE is happening. If there is a normal ICMP packet, you cannot find the GRE generic routing encapsulation, but your ICMP is going to be encapsulated right now, and it is going via the GRE, and that's why you can see GRE is using here to just send the packet, and this is my packet. My source packet is this one, destination packet is this one, and they just using the GRE flags because your GRE is just encapsulating the packet. So original header is basically, you can see, this is a protocol number 47. Based on that, they are encapsulating the packets. I told now they're using the protocol number 47. So this is my encapsulation protocol. Your source is going to be this one. Destination is going to this one. This is your actual encapsulation protocol, which is building the GRE source and destination. But actual packet is going via this to this destination. So it's clearly proving your GRE tunnel is up and working, and based on that, you're sending the packet. And even trace is also showing that. Even you go here and try to trace again here, 192.168.10.10, it is going via the GRE tunnel. So I hope GRE is fine for everyone. Clear? GRE is good. Guys, any question in GRE?
No, sir.
All right, good. Thank you. Okay, so let me discuss about the IPSEC. Let me stop this recording. Now we have to discuss about the IPSEC. IPSEC is going to be quite complex and it's going to be very lengthy. So try to understand. So first of all, we have to understand the GRE problem, and then we have to discuss about the IPSEC fundamentals. Theory is going to be a little bit big, then we'll do the configurations. So problem with the GRE is everything is going in the plain text. Means anything you're going to send in the GRE, it's going to be in plain text. Anyone want to hack, it is possible, they can hack. IPSEC, IP security, it's a complete encrypted. Complete encrypted, that means whatever traffic you're sending and receiving, nobody is going to understand what data you're sending, what data you're receiving from the two branch location. So it's going to give the security. But you might be heard about GRE over IPSEC. Sometime you might be going to heard, you also going to find GRE over IPSEC. So what is GRE over IPSEC? Why GRE over IPSEC is going to be used? So GRE over IPSEC is going to solve one of the problem which having a GRE and also IPSEC having one problem. So bigger problem with IPSEC is it's only support the unicast packet. Unicast packet means it's going to support static routing one-to-one communication. It's a very secure, right? It's a secure, but having a problem as a unicast. If you want to run the BGP here, you want to run the OSPF here, you want to run the EIGRP here, it is not possible to run with IPSEC. GRE problem, it's a plain text, it's a non-secure. But the biggest advantage, it support multicast packet. Multicast, anything can be used. Means if you want to use the BGP, EIGRP, static, that's all possible. So it's a flexible but not secure. GRE is basically going to be flexible but not secure. This is not flexible but secure. So if I want to use the flexibility, I can use the GRE, and I want to use the security, then I can use the IPSEC. So if I merge this together, then I will get the flexibility plus security, both. That's why you are going to find most of the case GRE over IPSEC. Means the both protocol is going to work together. In that case, you are going to use the any kind of the communications. It's a unicast, multicast, BGP, OSPF, everything is possible. So this is the key difference between the GRE and IPSEC. I hope this is clear to all. In case any doubt, raise your hand. Now, we have to understand GRE is going to just encapsulate the packet. It's going to build a tunnel. IPSEC also going to do that, but they are going to create the secure tunnel. It is going to get unsecure tunnel. So if I go and read the IPSEC fundamentals, so IPSEC is an open framework that creating a very highly secure tunnels, right? Virtual private network, VPNs, using the various protocol and technology to secure your communications. Means if you want to secure your communications over the public network, that is the internet, then you have to build your IPSEC. That's why IPSEC is going to be used everywhere. So there is a 4 pillar of the IPSEC, that is a peer authentications, data confidentiality, data integrity, and reply directions. So what is that? Means anytime if you want to build any IPSEC tunnel, so very first thing, if there is 2 routers want to negotiate for the IPSEC tunnel, so whatever the peer key, means whatever the key you have and whatever the key you have, both should match. Both same. If they are not going to be same, you cannot form the IPSEC tunnel. That is the very first thing. Additional digital certificate. If you are not using the pre-shared key, means you are using the more highly secure method, that could be your digital certificate. So you can use a digital certificate as well. So certificate is going to also use to authenticate whether you are the right peer or not. If in case you are not right peer, you're not going to be authenticate, you're not going to allow to form a tunnel. So the peer authentication is going to verify, is it my legitimate peer who is trying to build tunnel or not? So verification is going to happen before anything you're going to negotiate. That is a peer authentication. Now the second step comes as a data confidentiality. Data confidentiality means whatever data I want to send from there, it should be confidential, it should be encrypted by using the DES, data encryption standard, triple DES, AES, advanced encryption methods, whatever you want to use that. So you have to make sure whatever data you're sending and receiving from site A to site B, this all must be encrypted. Okay, so that is the confidentiality. Means protect data from the eavesdropping attack through the encryption algorithm, change plaintext into encrypted cybertext. Means anything you're sending. And how encryption decryption look like? Let me show you. If I go in the internet, IP packet encryption and decryption online. So you're going to find a lot of tools and you can just sense how the encryption decryption is going to happen. So let's suppose I can put in anything. My name is Pankaj. So this is my encrypted data. So I want to encrypt with a secret key 1, 2, 3, 4, 5, 6. So this is my data. You can see. So once my data was this one, my name is Pankaj, but the moment my router want to encrypt it, so by using the encryption key, they encrypt the data is going to be like this. Can you read this data? No, you cannot read this data. Another end, once you want to decrypt it, so just put this data, enter the decryption key, same key 1, 2, 3, 4, 5, 6, and see my name is Pankaj. So unless or until you have the both key are same, right? Your key is going to match. You're not going to encrypt or decrypt the data. So this is how encryption decryption is going to happen. So you completely going to get a raw data which almost not able to read by anyone who are in the middle of the internet. Because the way encryption decryption is going to happen is a very powerful encryption decryptions, because they use the method is the AES 128, 256, 512. There are 384. So there are multiple way of doing the encryptions. Now, so peer authentication, data confidentiality, encryption, decryption. Third one is the data integrity. What is data integrity? Data integrity is the method. Let's suppose I am not able to understand what data you're sending. Okay, that's fine. Let's suppose you're sending 01010101, or might be, let me put in this way. I want to send the 10,000. Okay, this data I want to send. You're not able to understand what data you're able to send. But I can do some manipulation. I will try to exchange some order of the packet. There is a possibility, man in the middle, hacker sitting on the internet who not able to understand, but who will insert the dummy data, who will just change the sequence. Like your data is going to be exchanged, not understand, but they will do some hashing method. They are going to do some padding where your data is going to be exchanged. So by sending the data, you're receiving this 0001. So almost you are going to be loss. If you're sending the rupees transaction or dollar transactions, 4 times 9 USD might be going to loss. You're sending 10,000 USD, but you're receiving only 1 USD. So this is the power of the data integrity. Data integrity, that is a prevent man in the middle attack by ensuring the data has not been tampered during the transitions. Means anyone want to do the tampering the data during the transitions. So this data integrity is going to make sure that tampering is not going to be happen by using the method that is known as the MD5. That is known as your secures hash algorithm. These are the method HMAC methods. So that is going to make sure whatever data integrity is going to maintain throughout the travels. So this is my data integrity. Last but not least is the reply direction. So what are reply directions? In reply directions, your data is not going to be compromised. Peer is going to be authenticated, integrity is going to be there, but still what is going to happen? Let's suppose you are building a tunnel. This is the R1, this is the R2. You build a tunnel. Okay. I'm not going to compromise with your integrity. I'm not going to manipulate your data confidentiality. I'm not going to do any kind of peer authentications. What I can do, I can add one more new router here, R3. And I will try to intercept your all VPN tunnel. Means I will just hijack your VPN tunnel and I will form a illegitimate VPN tunnel from myself. And this tunnel is going to be completely hijacked. So this router will think I'm talking to R1, but technically it's start talking to R3. Get my point? So reply direction is the method. Prevent man in the middle attack where attackers capture the entire VPN traffic and reply it back to peer with the intention of building the illegitimate VPN tunnel. Means this is the wrong tunnel, but he will think I'm working with the right tunnel. So this is also possible. So how we can stop this one? So this can be stopped with the reply direction. So what happened? Whenever negotiation is going to be happen between the routers, R1, R2, R1, R4, any router, so they maintain the special sequence number. And if that sequence number is not going to match or not going to be, or any process sequence number is going to be there, they will not accept those kind of the tunnel should be allowed. So whenever you're going to build the IPsec tunnel, you have to be keep these or 4 fundamentals in your mind. That is a peer authentications, data confidentiality, that should be the data integrity and reply directions. Any doubt here? Anyone? Amrita, Battalion, Jitendra, Sek, Sridhar, Nemai, or Nemai, sorry. Any questions in this particular slide?
Either
No.
this digital certificate is a private certificate or is a public certificate.
It's a private certificate. Generally, we use in IPSEC private certificate on certificate, not public
Okay.
certificate, because it's a private tunnels, no, site to site.
Is it any possible to create a private certificate in that router itself?
Yeah, we can create. We can
Okay.
build the root. You see, na SD when we create the certificate, na Amrita.
Yes, sir.
SD when we created na root CA certificate. Under that we issue the certificate. That is a
Yes, sir.
digital certificate. We can create that.
Okay.
And
The
there is a
normal
tool.
in normal router it's possible.
Normal router only is possible. In the SD
Okay.
WAN, we creating. There is a tool 𝗂𝗂𝗋.
I'm not asking in the SD-WAN device. In the normal router,
In,
like
in
common
SD,
router.
you done the SD WAN, Amrita?
Yes.
In SD WAN, there was a root CA. That was a normal router only. What I'm talking. That was not SD WAN. Root CA was a normal router. Just log in and try to check that. Okay?
Okay.
That is a normal router only.
Okay.
That is the normal router can become my root CA. So you can see another tool if you want to create a certificate. This is another tool. You can create the certificate from there as well. So for your
Okay.
organization, it is going to create a certificate. You can download this 𝗂𝗂𝗋 certificate creation tool is available. Window for the Mac. You can use that.
Okay, sir. Thank you.
Battalion, you clear? Sheikh, Sridhar, Nemai,
Yes.
all good till here? Shall I move? Okay, good. So moving further, guys, and the next step, IPsec is going to use the 2 protocol. One is the authentication header, that is known as the AH protocol. So this is my AH protocol, and this is my ESP protocol. This protocol is going to be protocol is going to use the protocol number 51. This is going to use the 50. GRE, we know that is equal to 47. So if I'm going to use the AH having a major 2 problem. Okay, what is the problem? Out of these 4, it not support data confidentiality. AH, if you're going to use a protocol, IPsec, they not support data confidentiality. You can see authenticator headers does not support data confidentiality. So means if you're going to use the AH, your data is not going to be secure. It's very highly possible anyone can manipulate your data. So that's why it's not recommended to use the AH. That is the one reason. Another reason, there's a one concept is the NAT reversals. So it not support the NAT reversals as well. NAT reversal is a feature where my IPsec tunnel want to build behind the means one of the NAT router, and behind the NAT router I have another router that is a private network, and I want to build my NAT T. So in case of that situations, If I want to use the age protocol, that is not going to be supported. So that's another major issue we have. But ESP is having all kind of the fundamentals, means everything is going to support by the ESP, everything. So that's why you're going to use always the ESP protocol for the IPsec communications. Clear? Now, when you're going to use the ESP, you are going to use the, means ESP use the protocol number 51 also, it might be somewhere written, you can, sorry, 50, so there. Now, ESP is going to use two mode. One is going to be tunnel mode, another is going to be a transport mode. So this is my tunnel mode and this is my transport mode. So to understand what is the transport mode and what is tunnel mode. If I talk about the transport mode, your data, okay, your data is going to be encrypted only. Only data, if IP packet having the data in IP packet, the only data is going to be encrypted. And your original IP header is going to be available to switch the packet. Means the original IP header is going to be available to just pass the packet from one hop to another hop router. Means you have the travel to the packet. Means how packet is going to travel based on the IP. So they are not going to add any new IP address. They are going to keep your IP address as a same original, but they will encrypt your entire data. Every data is going to be encrypted. But in the tunnel mode, what happened? Whatever your original packet is going to be there, IP plus data, original IP plus data, they all are going to be encrypted. They will add the new IPsec header so that my packet is going to be switched from one hop to another hop. So this is the difference between your transport mode and tunnel mode. Clear? So transport mode, that is only going to be encrypt your data payload. Your original header is going to be still free, and your tunnel mode is going to be encrypt your entire packet. Means everything is going to be encrypted, even the original IP packet and the data, and your new header is going to be added. And based on that new header, your traffic is going to be processed from one location to another location. Clear? Okay. Now, these are the methods. Data encryption standards, triple DES, means they are the encryption method. We discussed the hashing methods also, right? But also means the already discussed, right? IPsec support the following encryption, hashing, and keyword. Means whatever we discuss here, the same thing they are talking about. These are the encryption method, hashing method. So they are talking the same thing here. Keyword all encryption method and hashing method, they use that. Now they use the transform set. Okay. What is a transform set? This is the special. If you're going to use the IPsec tunnel in the Palo Alto firewalls, FortiGate firewall, checkpoint firewall, you're not going to get transform set. But if you're going to use the Cisco router, right, you're going to use the transform set. Means always you're going to configure transform set. Even you can see here somewhere transform set. You can see this is my transform set. So what is the use of transform set? So transform set is the combination of the security protocol and algorithm. Means whatever the algorithm and security protocol we discuss here, that is going to combine in the transform set. During the IPsec security association, SA security association negotiation, the peer use a particular transform set for protecting particular data flow. Means this transform set is going to decide how my negotiation is going to happen to make sure we are the right peer. And then after it is going to be decide my data flow pattern as well. When such transform set is found, it select and apply an IPsec security association on both peer. So you can see there are transform set, different headers are going to be there. Means HMAC for the authentication, higher authentication, you can use this one HMAC as well. So these are different transform set for the higher security level, and you can use for the your authentication here. AH you can use this transform set, and ESP you can use this transform set. So these are going to be used. Clear? So we'll discuss how transform set is going to be configured even in our scenario. But transform set is also going to be used. Now, in IPsec, we are going to use the protocol that is known as the 𝗖𝗍 protocol. Whenever going to build IPsec tunnel, the IPsec tunnel is going to use the 𝗖𝗍 protocol. So what is the 𝗖𝗄𝗃 protocol? 𝗖𝗄𝗃 protocol is the internet key exchange. It is going to make sure to have the phase 1 negotiations. Means 𝗖𝗄𝗃 is going to be make sure we have the phase 1 negotiations. Means they have the phase 1 and phase 2 negotiations. So initially they are going to be make sure we have the phase 1 negotiation, and then they are going to be allow phase 2 negotiation. So what is the phase 1 negotiation? What is the phase 2 negotiation? So let me draw one of the diagrams so you guys can understand. So in IPSEC, you're going to build one of the tunnel. Inside this tunnel, you are going to build another tunnel. Okay. So this is my, sorry. This is my phase 1 tunnel. And this is my, Jitendra, anything you're saying? Phase 2 tunnel. So my phase 1 tunnel and phase 2 tunnel. Phase 1 is basically known as your control tunnel. This is known as your data tunnel. So that means any packet is going to be processed, actual packet. It is always going inside of your phase 2 tunnel. Means actual traffic. Actual data traffic. But to build the phase 2 tunnel, your phase 1 should be up and working. If there is no phase 1 tunnel, right, you cannot build the phase 2 tunnel. So your phase 1 first should be there. Control tunnel is going to give the secure control environment. Based on that secure control environment, you can create another secure control environment. And inside of that, you're going to send the packet. That is a phase 1 is the outer tunnel. This is the inner tunnel is phase 2. So same thing they are talking about. You can see internet key exchange is the protocol that performing the authentication pair between the two endpoints to establish the security association. The control connection, also known as the 𝗖𝗄𝗃 tunnel. This security association used to carry the control plane traffic and data plane traffic. So who is going to carry the control plane? That is a phase 1. So here you can see 𝗖𝗄𝗃 is the phase 1 tunnel, and this is the phase 2 tunnel. Is going to be data tunnel. So you can see they are talking about the establish the bidirectional security association between two 𝗖𝗄𝗃 pair, also known as the ISKMP tunnel. So ISKMP is known as the Internet Security Association Key Management Protocol. So this protocol is going to responsible to build a phase 1 tunnel. That is my control tunnel. And then we use the another protocol, that is the IPSEC. This IPSEC is going to use for the phase 2 tunnel. So we have to build these 2 tunnels. I will show you how phase 1 is going to build and how phase 2 is also going to build. Now, whenever you're going to build the phase 1 tunnel, this tunnel is going to use a 6 packet exchange. 6 packet exchange. Phase 1 tunnel can be work in the main mode and the aggressive mode. Phase 1 tunnel can be work in the main mode and can be aggressive mode. So if I'm going to use the main mode, then it is going to exchange my 6 packet. And if I'm going to work in the aggressive mode, then it is going to use my 3 packet exchange, AM1, AM2 and AM3. So what is my 6 packet exchange? So if I talk about the phase 1, 6 packet exchange, so first package is going to be sent by your initiator. There is a 2 role. The packet who is going to send, that is known as the initiator, and another router is going to become a responder. Based on that, your packet, they're going to reply back to you. What information you send, is it matching my database or not? My security solution matching or not? If it is not matching, it is not going to be replying. So you can see here in MM1, what is the method they're going to send that? So they are sending the parameters. What parameter? These parameters. Key, data confidentiality, data integrity. You can see same thing they are sending here in the phase 1. In phase 1, MM1 message means what is my hashing algorithm, what is my encryption method, what is my pre-shared key, and what is my Diffie-Hellman group, and what is my lifetime. These 5 parameters they are going to send in the first message. Based on that 5 parameters, MM2 is going to reply. If that is going to match, then it is going to reply with their security parameter. If that is match, if not match, then there is no meaning to reply. So if match, the message sent from the responder to initiator with the security proposal that is matched. Agar nahi matched, no reply. So the first package is going to send this 5 parameter. Based on that, if it is going to match, then it is reply. Once this match reply is going to come the MM2 message, MM3 is going to exchange Diffie-Hellman key, and they start building the communication. Based on that Diffie-Hellman key, responder send their on key initiator, and that at this point encryption key has been saved. Means encryption decryption key need to be created. That is going to help with the Diffie-Hellman key exchange process. And then if you have any additional authentications, then you can just start doing the IP address based authentication, any FQDN based authentication. So in MM5, the initiator start authentication by sending the peer router IP address if they are required to authenticate. And then finally your authentication is going to be happen. And then your 𝗖𝗍𝗡𝗏 tunnel, that is the phase 1 tunnel, is going to be established. So this is your MM1, 2, 3, 4, 5, 6 message exchange is going to happen in the phase 1. If you are going to use the main mode, so here, if you are going to use the main mode, then you are going to exchange this 6 packet. If you are going to use the aggressive mode, then in that case, you are going to use the AM1, AM2, and AM3 message. This AM1 is going to be sent 3 message combination out of 6. Means they are going to be use the property of the MM1, MM3, and MM5. And then in reply of that, they are going to get MM2, MM4, and MM6. And then MM3 is going to finally 5 message. So it's going to be faster, but they have the lesser security. They are going to be fast, but doesn't offer the same level security what my main mode is offering. So it's a lesser security is going to be available. All right. So this is my phase 1. So phase 1 can be 2 message type, 6 packet exchange, 3 packet exchange. But if you go to phase 2, only 3 packet exchange is going to happen. That is a quick mode 1, quick mode 2, and quick mode 3. In quick mode 1, again, the security association is going to be exchanged. And then means security association, what is your algorithm? Your hashing method, encryption method, authentications, IP address, everything is going to match. And based on that, your quick mode 2 is going to be get reply, parameter is going to match, and then your security association is going to build. And in this tunnel, your actual data packet is going to be travel. So this is how you can configure the MM1, MM2, and MM3 message for your different kind of the IPSEC build for the phase 1 and phase 2. Any doubt? And similar, we have the 𝗖𝗍𝗡 protocols as well. 𝗖𝗍𝗡 have the different set of the message type. This is the old version, this is the new version. So main mode has been replaced with the 𝗖𝗍 security association initialization SA init mode. Aggressive mode has been 𝗖𝗍 auth. Quick mode has been create child SA. In that case, 𝗖𝗍1, we are using a 9 message with the main mode. Why 9 message? Because main mode, if you are going to use 6 packet exchange plus 3 for the quick mode, then it's become a 9. And if you are going to aggressive mode, then it is going to be 6. Why 6? Because aggressive 3 packets and the quick mode 3 packets is going to be 6 packet total. 3 this one and 3 this one, 6 packet. If you're going to use the main mode, 6 plus 3, this one is going to be 9. But in case of the 𝗖𝗍𝗡, 𝗖𝗍 version 2, it's only 4 packet is going to be exchanged. And these are the supported authentication method. 𝗖𝗍 version 2 support more authentication methods, advanced authentication methods. Next generation encryption not supported by the 𝗖𝗍 version 1. Give me 1 second. This is going to supported by the 𝗖𝗍 version 2. Even they support only the man in the middle protections and eavesdropping protections, but it is also support the anti-DDoS protections. So we can use the 𝗖𝗍 version 2 as well. almost you are going to find a similar configuration, almost similar, only version need to be changed, or IK version 1 as well. There is no problem. But you should know a little bit this fundamental. Clear till here? Now it's time to do the configuration. Means if I want to build you can say in the Cisco, there are a lot of VPN we can understand. They have the side-to-side VPN, Cisco DM VPNs, Cisco Gate VPNs. These all are Cisco only, but side-to-side is a multi-vendor. But rest is your only Cisco proprietary protocols. So IPsec, like you can scale up to low. This can be thousands of the hub and spoke, thousands, or remote access VPN is like by setting in the remote location you want to connect. So when you're going to learn the firewalls, you're going to get this all information. But we are going targeting this IPsec VPN side to side. And in that, we can do all kind of the configuration, LAN to LAN configurations. DM VPN is going to part of the CCNP NRC. We'll discuss about that. And these all are gate VPN and all are not needed. But you can see this is the how GRE packet is going to be there. ESP header is going to be added in IP. This ESP for the IPsec that is going to give the encryptions. And then GRE over IPsec is going to build, then your packet is going to be processed from the network. So these are all the configuration. So we can start doing the configurations. If any questions, please let me know. I will help you. Now we already built the GRE tunnels. Now we have to build the IPsec tunnels. So let me close this one. So if I want to build the IPsec tunnel, how we can build the IPsec tunnel? So GRE over IPsec. So GRE tunnel is already created. Now we have to encrypt that tunnel. So before I can go and configure that, encryptions. Earlier we see only when I capture the packet capture, we only see. Let me do again the packet capture. We not seen any kind of the IPsec packets. Let me try to show you something. Wait for a while. So you can see in this, we not able to see any kind of the IPsec packet right now. Means we only see the GRE packet, but there is no ESP protocol, AH protocol. You're not able to see anything here. See? But when I go and configure again this with IPsec, then we'll see this negotiation is going to happen across the site. So I'm going to make the configuration. Right now, GRE is configured, but I will configure GRE over IPsec and we'll see how it is going to be communicate. So very first thing, when you go to configure GRE over IPsec, the very first thing you have to configure the phase 1. So whatever the phase 1 you're configuring on the site 1, it should be exactly matched to the phase 1 of the site 2 as well. Means same parameters. Everything should be same. So that you can go here and create the crypto 𝗖𝗖𝗡𝗄𝗣. Sorry, 𝗖𝗖𝗡𝗄𝗣. This is the phase 1. 𝗖𝗖𝗡𝗄𝗣 protocol is the phase 1 protocol. You can see here is they use the ISK. So I'm doing the configuration of the phase 1 and I can give any policy number, any number. Let's about 10. Now I need to give the encryption method. What encryption methods? I can choose any encryption method from this list for data confidentiality. I can use a DES, 3DS, AES. So let me use a 3DS. Okay. 3DS. Now I will use the authentication. Authentication, I will use the pre-shared key. See, authentication, I have a two method, digital certificate and pre-shared key. So I will use the pre-shared key and I will give the group name. So pre-share, and then after I will define the key later on. So I will give the later on key. So group is going to be Diffie element group. I will give the anything. Let's suppose I give the 2 or 5, anything I can give. And lifetime of this particular phase 1, it's going to be by default 86,400. So I will give that. Now, what is my pre-shared key? So my pre-shared key is going to be, I can go here and configure crypto 𝗖𝗖𝗡𝗣, and key is going to be, let's suppose I am going to give the key as a test@12, and peer is going to be, my address peer is going to be this one. I can use this peer 1110 15 11.2. You can use the 000 IP address as well. There's no problem, right? So this is my peer, and 1110.15 okay, that's fine. So now my phase 1 is done. Now let me go and run command show run section crypto. So this is my phase 1. So I will copy the same configuration, exactly same configuration till here, because peer need to be changed. I will paste in the my router 2. I will just change my peer this time. Peer should be 1112.16 1112.16 10.2 10.2. Okay, that's fine. So my phase 1 configuration is done. Exactly whatever the encryption, authentication, whatever thing you're using should be same. Key should be also same. Only your peer should be changed. There's no problem with the peers. That's fine. So your phase 1 configuration is done. Okay. Now it's time to do the phase 2 configuration. How are we going to do the phase 2 configuration? Phase 2 is going to be done by the transform set. So you have to configure here. Let me create that configuration crypto. Phase 2 is always with the IPSEC. Okay, and then you have to give the transform set. This transform set you have to give the name, like I'm using the GRE over IPSEC. GRE over IPSEC. And now you have to give the encryption method. So what is the encryption method? I can use the ESP 3DS. Again 3DS. Okay, and then you have to use the authentication, means this one I'm talking about data integrity. Okay, data integrity, I can use the ESP MD5. Let me use the MD5 HMAC. So this is done. And mode, what is the mode of this particular tunnel? So mode of tunnel, you have the two options. You can use the transport mode or tunnel mode. So I will use the transport mode. Transport mode is a more secure. It's going to be transport mode is less secure, tunnel mode is more secure, but it's going to be faster. So transport mode is only going to encapsulate your data. This is going to encapsulate your payload as well. So it's a fast, lightweight. So I can use a transport or tunnel, whatever you want to use that. Done. So this is my phase 2. Now I will just copy this configuration, show run section crypto IPSEC. I will copy this entire configuration for phase 2 and I will just paste here as well. Both sides should be same. Nothing should be changed. So this is also done. All right. Now next, I have to create my crypto profile, and then crypto profile, I need to call my this phase 1 or phase 2 parameter together so that I can apply them to the my tunnel interface. So how I can create, because I need to protect my GRE tunnel. So I can create my crypto IPSEC profile. This IPSEC profile, I can put my any name, like I can put the GRE protect. I can put the GRE protect. Means I want to protect my GRE, and I can use the site security associations, right? This is going to be lifetime, and that value is going to be in seconds. It is going to be just use like 86,400. I can use the default value. And what is my transform set? The phase 2, that is a set transform set. That is the name is going to my GRE over IPSEC. This one. So I can use the GRE over IPSEC. That's all. Same thing. What I can do that, I can just go here and I can run the command crypto IPSEC profile. I want to check the profile. I will copy this profile clearly from here, I will paste this the R2 router as well. So I want to make sure both routers should have the same configuration. Done. This is also done. Last option. So let me show you what I have done till now. Let me show you one by one. So I created this phase 1. Okay. This is my transform set phase 2. Okay. Now I just call this phase 2 in this phase 1, and security association is going to be take whatever security association I created here, phase 1. Now I need to call this on my IPsec tunnel so that they are going to be protected. Means the tunnel which I created here, this need to be protected. So I will call this under my IPsec tunnel. So how we can call it? I will go here, interface, tunnel 101. And here I will give the tunnel protections, and this tunnel protection is going to be my IPsec, and profile is going to my this profile, GRE product. Done. And I will copy the same thing, show an interface tunnel. See, my tunnel is down right now. I will just copy the same thing. So I will go here because name is same. So I will copy the same here. I will go here and I will call this protect as well. Same thing. Now done. So you can see your tunnel went down, but now it should come up. Show IP interface. So your tunnel is showing down. No problem. We'll try to send the interesting traffic. Let me try to send the interesting traffic. Okay. Why it's down? Okay, let me see. There's some crypto show run section crypto test 1.2. Let me check the peer 112.16.10.2. That's fine. Let me say show. This is fine. Show crypto. Sorry, ISKMP. So my phase 1 is fine. You can see phase 1 is completely okay, right? So IPsec show crypto IPsec. Phase 2 also fine. We are doing the encryption decryption properly, but we are not able to talk. Means my phase 2 is fine, phase 1 is fine, but my packet is not going on. Tunnel is up. You can see my tunnel is up, but somehow my ping is not working. Tunnel is up. Your traffic is not passing. Let me do one thing. Show interface tunnel 101. Let me remove the keep alive. Keep alive creates sometime problem. Let me remove the keep alive. Interface tunnel 101. No keep alive. Let me show. So you can see tunnel come up and see your communication start happening. So there is an issue with the IPsec. Whenever you're going to configure the IPsec and you're going to configure the keep alive, they are always going to create a problem. Keep alive is not compatible with IPsec. You can see the tunnel was up. You can see my IPsec was up, right? Phase 1 was also up. Phase 2 was also up, but my tunnel was showing down. And this is something very weird. So if you check in the Google as well, why with GRE over IPSEC, why keep alive, make tunnel down in case of GRE over IPSEC. You just try to search, you're going to find the articles. So see, keep alive mechanism GRE over IPSEC scenario often bring the tunnel interface down because they are designated to detect if the remote peer is unreachable. Okay, so whenever you're going to configure the IPSEC, by default, you're working in the encrypted environment. Okay, because your entire packet has been encrypted. So so they frequently fail properly route decrypted, landing to the false negative. GRE tunnels inherit the stateless, meaning without 𝗂𝗋𝗯 router will keep interface up even they are underlying the IPSEC security association is dead, creating the black hole and send the never. So why 𝗂𝗋𝗯 tunnel down failure purpose failure to propagate the 𝗂𝗋𝗯 when GRE encrypted the IPSEC GRE 𝗂𝗋𝗯 packet must be correctly encrypted, transmitted and decrypted the peer. The IPSEC goes down, it's a 𝗂𝗋𝗯 packet. So basically, whenever you're going to create, right, GRE is always going to be create a problem. Means if you're configuring with the 𝗂𝗋𝗯 methods, it's always going to create a problem. So always you have to remove that 𝗂𝗋𝗯 method, or we have to use the different method to just build the IPSEC tunnel without GRE. So they are going to be make the tunnel up and working. So I will tell one more scenario how we can avoid that situation with the 𝗂𝗋𝗯 as well. But for time being, you can see we are able to encrypt and decrypt the packet. So now my packet is getting encrypted and decrypted. You can see my communication is happening here. If I'm trying to ping from here to here, able to ping. If I'm trying to ping from here to here, able to ping. But this time the packet is going via the IPSEC, because you can see here, show 𝗖𝗖𝗡𝗵 show crypto 𝗖𝗖𝗡𝗵. This mode is going to tell you your tunnel is up and working. This is a phase one. Phase one is going to be show your tunnel is up or working. Now, if you go and check the phase two, then you have to run the command show crypto 𝗖𝗖𝗡𝗵. You can see the number of packet you're going to encrypt and decrypt almost should be similar. It's not should have the major differences. If there is a differences, that means your tunnel is not, phase two is not carrying the correct data. So you can see transform set, what encryption method they are using, hashing method they're using, that also showing that state is active. Means it is a up and working. Now, if I want to do the packet capture, so I can go here, capture interface, and you will see after that we are going to get the GRE or IPSEC packet capture. So we have to wait for a while. So let me start this and let me initiate the ping. So I'll go here and initiate the ping again. And see, now you are able to see the ESP negotiation. That is a very important ESP negotiation, and GRE negotiation not coming. Why? Because GRE is completely encrypted under the ESP. GRE is completely encrypted under the ESP. So that's why you're not able to see GRE packet, any GRE packet. Only you're able to see the ESP. Make sense? So this is how you can build the IPSEC over GRE. What we can do, guys, just take 5-minute break and we'll continue